Okay, in these next two classes, we're going to look at all the different applications you could do with matrices. So we spent a lot of time learning a lot of operations with matrices, how to multiply them, how to transpose them, how to find determinants and inverses. Now we're going to get in some real-world applications of them. So the most common one, or I don't know, maybe not the most common, but for us the most common, and well, we're going to use matrices to solve a system, but not how we've done it before with multiplying by writing the matrix like this out with the coefficient matrix, and then multiplying it by the variables, and then setting it equal to the answers, and then using inverses. All right, it's actually an easier way than that, and it's called Cramer's rule. So another way to solve a system using matrices. We already know one way using inverses, now a Cramer's rule. It's pretty easy once you get the hang of it, and it involves finding determinants. So step one is we're going to find the determinant of the coefficient matrix. So that would be pretty much this matrix right here without x and y. And we're going to get that number. So it's going to be 27 minus 20. So that's 7. Right? So that's called D, just the determinant of the coefficient matrix. Then D of x means you take that same exact coefficient matrix, but we replace the x numbers with the answers. So like 3 and 4 get replaced with 7 and 11, right? Like right there. So now we find that determinant. So we cross multiply, we do 7 times 9 is 63, minus 5 times 11 is 55, all right? And we get 8, okay? Then do the same exact thing with D of y, but now instead of replacing the x coordinates, we're going to replace the y coordinates with the answers here. So we got this original D matrix, but we replace this column here with 7 and 11. Alright, we cross multiply and we get 33 minus 28, which is 5. And our final answer is we're just going, so x is going to equal D of x over D, and y is equal to D of y over D. So even if you have a system where the answers are fractions, it's super easy, and if you don't believe me, I'll solve it on the calculator right now to show you that it's the same answer. Okay, and there it is right here on the calculator. We got the same answer if we let the calculator solve it. And you might be thinking, well, can't the calculator just do this? Why would we use Cramer's rule? And you're right. If you ever just have to solve a system in a pinch and you have the CAS capabilities of the calculator, go for it. But it's a good, before we had calculators that could do all this for you, this was a nice easy way to solve systems, especially bigger ones. So let's look at a 3x3 in the next video.